primary alcohols can be dehydrated if treated with a strong acid and heat. The product of an the E2 reaction of a primary alcohol would not be a very substituted alkene. So it's going to be a higher energy intermediate. And so we still see this trend in terms of reactivity, that primary alcohols react slower than secondary and tertiary alcohols. And they also go through a different pathway. With a primary alcohol, you can't form a stable carbocation. So we're looking at an E2 pathway rather than an E1 pathway. So I'm going to draw an example of an E2. So we're going to look at 1, 2, 3, 4. We're going to look at butanol, and we're going to heat this up with sulfuric acid. And the product might not be what you expect it is. So I think it's important to take a look at this mechanism. So the first step, that acid is going to react with the alcohol because the alcohol can be a base. And so the lone pairs of electrons on that alcohol will pick up a proton from the sulfuric acid. And so that has taken a poor leaving group, right? Hydroxide would not be a good leaving group. It's too strong of a base, and converted it into a neutral water molecule that could be a good leaving group. And so if this were a secondary or tertiary alcohol, that leaving group would just leave, but you're not going to form a primary carbocation. So what's going to happen instead is you will take a hydrogen from the beta carbon with your base. So this is going to be a concerted step. That's why it's E2. It's bimolecular. So the water molecule is going to take the hydrogen. Those electrons from the carbon-hydrogen bond come in to form the pi bond, and then you push off the leaving group. And so the initial product is going to be the butene. So I've got one extra carbon atom on here. Let me get rid of that quickly. Okay. So we've got the 1-butene as the initial product. So 1-butene. But you're still in acidic solution. There's no way to stop this reaction right now and just say, okay, it's done, right? You would not be able to do that so quickly. So if you have butene in a solution of aqueous acid, what this 1-butene is going to do is it's going to isomerize to give you a more stable alkene product. So if we protonate this alkene, because we've got lots of aqueous acid around in here, then we're going to get a secondary carbocation. Right, so there's the secondary carbocation. And now from here, you can eliminate to give a more stable alkene. So we can take one of these beta hydrogens, and it will abstract one, so the water will abstract one of those hydrogens, and the electrons come in to form the more stable alkene. So we still tend to see the most stable alkene as the major product of an E2 reaction.